So we go to NumPy arrays. So this is what you'll need in this course, NumPy arrays. List you don't work too often, but we work with, well, we'll work with list, but more often NumPy. So these arrays, NumPy array. So NumPy is a numerical Python. Okay, so please keep in mind, this is a short form. NumPy is short form for numerical Python. Now here, all the elements of the list are homogeneous. That means either integer or float or string. You can have a list of string. We don't need it for this course, but either we have integer array or float array. Okay, and data size is fixed. I cannot delete or append from an array. Okay, that's so it's a fixed data size. I think one student asked a question. So here, data. I mean, we cannot. It's not a dynamic array. It's a static array. List is dynamic, but array is static. It doesn't. The size does not change. And since I know that is all either integer or a float, that's why array operations are faster. We work with list. Of course, some operations are not allowed. But let's say I have a list of numbers, and I want to take multiply that number, all the numbers by 2. It will be faster with array, not with list. Okay. Now the array operations are optimized. So they are square root of all the elements of array. It is optimized, and they're accessing a subpart is optimized. One more point is arrays are in the memory, they are stored consecutively. List elements will not be consecutive. They can be scattered anywhere in the memory. But so since arrays are stored consecutive, one after the other, its access is also fast. Now I can't get into it because cache optimization requires that this list, the elements are consecutive. Okay, anyway, but we'll ignore that aspect right now. How to work with NumPy? So there was, I mean, I think in the you saw that in Pluto tutorial. So we can import. So I should be small, not capital. I should import NumPy as NP, or you can say from NumPy import star. These are two different things, two different functionality for importing. But we'll use the top one. Now you can look at the notes. What's the difference? This is connected with namespace, but we'll just use the top syntax more often. If you write a file like in Pluto, you should use the top line. Okay, and access the function of NumPy is np dot. So np dot square root, np dot array, like that. But this shortcut, which I do it in my notes as well as in this course, I like this one. So I just say ipython minus pylab. So it is essentially is going to import in the second line. So it just imports all the functions of NumPy. The pylab, Python lab, imports both NumPy and matplotlib, or pyplot of matplotlib. Okay, so we'll come to that matplotlib bit later. So it imports all the functions. So I don't need to put np dot. I mean, it saves me time and as well as a bit of headache to np dot. Okay. So I prefer this when I'm working on my laptop. But in Pluto, you have to do this. There's no other option. Okay. Now let's just do some examples. Why is array 1, 2? So it is similar to list, but I need to put this array function. So array is a function of NumPy. I didn't put np dot, but in Pluto you need to put np dot because I imported this using IPython, PyPylab. So array, so it has 2 elements, 1, 2. So the syntax is a bit different. No? So just see that I didn't say y equal to 1 bracket 1, 2, but I put array function. So it'll create a NumPy array. And when I say y, so it'll give this output. It doesn't give you, remember for list, it gives you 1, 2. It gives you. Now, D type. So I think maybe this is related to the question which was asked in the beginning of the class. So D type y0, y1 is a data type. So you can get data type for any object. So y0 is an object. Right now it is an integer and it's integer 64. Integer 64, integer 64. Okay. Now y star 2. So this is going to multiply each element of the array by 2. So what do I expect? 2, 4. 2, 4. So this is unlike list where it is replicate. It replicates the elements. So star 2 is integer multiplication. I need that for my computing. I do that. Now, size of y, I can get size of this 1D array. It's straightforward. 2. I can also get length. So this is borrowed from list. So these are exactly same as list. So when I say z equal to y plus 3, it creates another array where each element has 3 added to it. So what do I expect for this? So 1 plus 3 is 4 and 2 plus 3 is 5. So z is 4, 5. We can do more operations, element by element operations. So y is 5, 9. And there's another array z, which is 1, 4. So the 2 arrays of same size. Huh? So I can add y plus z. So what will that do? It will do element by element addition. So 5 plus 1 is 6, 9 plus 4 is 13. So 6 plus 13, 6, 13. I can multiply. It will do element by element multiplication. 5 times 36, 5, 36. And division also same thing. So this is very convenient. You don't need to do a for loop. You can simply just plus star z. So that is the beauty of Python. You are, I mean, you can do things in one line rather than doing loop and worrying about indices and so on. It's just so fast. So I'm going to show you at the end of the class why this operation is preferred. This is faster than doing via loop. I will illustrate it. Now, for mixed inputs, so we have 1.0, 2. So you can see that this is float, but this is integer. But when I say array, so it's going to convert. So if it's mixed array, then it's going to convert. Mixed is float and integer. So it's going to convert integer to float. So this is going to convert to float, and float 64. So this 64-bit float. Now we can get sum of array. Well, this is a list also. It works for list as well. So sum is 11 and prod is product. Okay. So I prefer an array. I should have put array here, but it works for list as well. Okay. So we can get sum in one line. You see, I mean, you don't need to do a loop and declare variable sum and so on. So it is quick. Now, two important functions for linspace and arange. So linspaces, I need numbers arranged in a line which are equispaced. Okay, now in finite difference scheme, I need to use this x which are equispaced point. So I say start, stop, and end. So start from real number start, end at stop. But how many numbers I do a sample? N numbers I sample. Now A range is slightly different. I start, I give the step. Okay, I give the step instead of giving the numbers, but I don't go all the way up to stop. I just stop. I mean, my last element is before stop. So let's take an example. So I go from 1 up to 10 in step of 1.5. So I'm using a range, but go up to 10, but don't include 10. So I go up to 8.5. Okay, I mean 1, 2. Well, it's step of 1.5, 2.5, 4, 5.5, 7, because the last element would have been 10, but 10 will be not included in the array. Now linspace 1 to 10 in with 6 elements. So this will include the 10. Okay, there are 6 elements, equispaced, but it includes 10. Arange 5, what will it give us? If we don't give them, it will take default value. So start will be 0 and step will be 1. So it will give us 0, 1, 2, 3, 4. Okay? But these are real numbers. Huh? Arange is like range, but for real. Now, multi-dimension arrays, we need multi-dimension arrays. So for many applications like 2D image or a 3D velocity field, I need that. So this is an array. So how do I declare this array? So you can see there's a 1 bracket, and within bracket there are 2 smaller lists. So these are first row and second row. I'm going to show you this. So let's look at the entries here. So first row is 1, 2, first row. Row is like that. Row is left to right. and second row is 3, 4. Now, this is the column 0 and column 1. Column 0, column 1. Okay, so row column. Had it been 3D, then you would have planes. So often we need 2D. So how do I access them? So I can access this as 0, 0. So row column. So row 0, column 1. This is row 0, column, this is column 0. Row 0, column 1. So the first index is row and second index is column. Okay, and both rows and columns start with 0. Now, one way, of course, is to access like this. It's a uniform array, but you can also access a 0 bracket 1. Okay, both are equivalent for this example. And what will that be? 0, 1. So this is 0, 1. So this is entry. So 2, 2. I can take eigenvalue of this matrix. So this matrix is different, 0, 1, 1, 0. So 0, 1, 1, 0. This is one of the poly matrices. Eigenvalue will give us this. Now, of course, it looks slightly complicated, right? So the array and another array. So here it is. Okay. So you have to understand this one. This is inhomogeneous array. So these are the eigenvalues, 1 and -1, 1, -1. So this is the first array. You see this first array, and this is another array. So this is the first row, and this is second row in this. So first row of the array and second row array, and within the second row we have another array. So you see, so this is an array within the second row, and then another array within this. So if I enter 0, 0, it gives an error. I mean, because it is inhomogeneous. I mean, inhomogeneous means some have more entries than others. So the way to go is you have to do like this. So why 1, 1? What will that give you? So this is row 0 and row 1. So row 1. So this row and column 1. Column 1 is this. So this is the list which will come. If I say 1, 1. But if I want to get here, then 1, 1, 1. So 3 brackets, 1, 1, 1. So I'm good here. So this is more general way to get there, and especially when data is not uniform, we need to. This is the only option. We can't get the comma option. So some more example, I can do square root of an array in one line. You can do log. Many things, sine, cos. I mean, there are many functions available in NumPy. By the way, these are not available for list. You cannot do all this for list. It is solely for NumPy. Quickly, so A range I already told you. We can also do by one line create zeros. So I want to create NumPy arrays of zeros with 4 entries, with 4 zeros. So this is zeros bracket 4. We can have ones, 4 ones here possible. I can have empty array. Entry is 0, but yeah, this is empty array, nothing in it. We can we can do random numbers. So the 4 random numbers is a uniform distribution between 0 and 1. Okay, so this is a uniform distribution. Now we can create a 2D array with all ones. So the 3 by 3 array. It is this. Now we can access. We can get size of this array. This is a useful function shape A. Shape gives you number of rows and columns. So it's 3, 3. Okay, I'm sorry, I did press fast. So 3, 3 is 3. First is the number of rows, and second is number of columns. Now, this is what I want to tell you at the end. So there are 2 ways I'm going to multiply 2 large arrays, very large arrays. If you do simple small arrays, I can't get the difference, but if you do with large array, I can get. So I create 2 arrays, A and B, and they are random numbers. And how many entries is 100 million, 10 power 8. So I import NumPy as np and np.random.rand. So I had to do this. Right now I'm not doing in IPython. This I ran it. I wrote a code in a editor, and like we say Pruter, and I just ran it. Now I can run it. So I create a C, the empty array, 10 power 8. Now I can multiply this by C equal to A star B, element by element multiplication. This is one way to do it. Other way to do is by loop. So I can do a loop. So how do I loop? I mean, okay, I've not done it right now, but this is straightforward. For I in range 10 power 8. So you see, I create this big list. I told you, I mean, I can make a list which is huge, but it doesn't really create the list. It will just generate on the fly. And Ci equal to Ai star Bi. Okay. Now there are two ways to multiply. So this entries will be exactly same for C. Okay. Now I can time it. So how do I time? So from date time is a library. From there I import is a date time. So I can get a current time by this function now, which is part of date time. So T1 is date time dot now, T2 is date time now. One before the operation, one after the operation, and I print T2 minus T1. Okay, I do the same for both. Now, which one will take longer? I mean, I would like to get some oats. I can see the chat box. You can put. The first one is a C equal A star B, that will put 0, and second one for loop put 1. So just keep putting. I mean, let's see. I have a few minutes. I want you to make a guess. So people with 0, 0, 0. No one for 1. I guess. Okay. Okay. So the loop takes 20 seconds, and this just multiplication takes 2.1 seconds. These are my old laptop, 2014 MacBook, and so you see 10 times speed up when I do this operation. So loop is not only takes more lines, but is also slower. And why is it slow? Now it's a bit technical, but you need to know this, because this is something which I want to communicate. So remember, I should told that in a CPU there are many registers, and it can do, well, there are a lot of hardware, and it can do many operations in one shot. Like ROM processor can do 16 multiplication, 16 floating point operations in one clock cycle. Okay. Now, if I do this kind of operation, C equals star B, so it knows that this, like, you can just think of assembly line. In fact, it's all borrowed from this assembly line of cars. So, I've not been to a car manufacturer, but you go there, all the cars are basically lined up. So the first car comes, and the first guy will put some lamp, and it just moves. Other guy will put tires, it moves. So this assembly line. Okay, so that's why, in fact, computer follows that. But since there are 16 operations, you can have 16 lines of these cars coming. Okay, 16 lines of cars coming, and the 16 operators who are doing in one shot, basically at given clock. So 16 cars done. Well, some tires put, next gear put. So that's how we can do more operations in one cycle by putting more assembly lines. So this is what is done in such kind of operation, optimization, and data is just coming in a big chunk, multiplied and sent back. So vectorization, this is called vectorization. So we don't take one number at a time, but we pull a chunk of numbers in one shot. Okay. C compiler would have done this. Would have optimized this part. Once it sees the line, C compiler would basically make it vectorized. This one, it will vectorize it. But Python does not do it. Okay, so this one is not vectorized. But in any case, so in Python, if you're running it, this is slow, and it's 10 times slow. So don't do this. You have to do this. Okay, and yeah. So I will end at this point.